Analytical chemistry is a branch of chemistry focused on separating, identifying, and quantifying matter. This discipline employs various techniques and methods to understand material composition and gather quantitative information about chemical substances. Analytical chemistry is pivotal across numerous industries, including pharmaceuticals, environmental science, forensic science, food and beverage production, and more. The field is traditionally divided into two main areas: qualitative analysis and quantitative analysis. Qualitative analysis involves identifying the components and constituents of a sample, while quantitative analysis seeks to quantify the amounts of these components. The cornerstone of analytical chemistry is its use of standardized methods and techniques to identify the chemical nature and concentration of substances. Several fundamental techniques and methods are utilized in analytical chemistry. Chromatography is widely used for separating mixtures into their individual components. Techniques such as gas chromatography, GC, and high-performance liquid chromatography, HPLC, allow scientists to isolate, identify, and quantify compounds in a mixture. Spectroscopy, which includes techniques such as mass spectrometry, nuclear magnetic resonance, NMR, and infrared spectrometry, is essential for analyzing the atomic and molecular composition of substances. These methods rely on the interaction of light and matter to provide detailed insights into structural and compositional properties. Electrochemical methods, including potentiometry and voltammetry, are extensively used for their sensitivity and precision in determining ion concentrations and redox status of compounds. The development of advanced instrumentations has significantly expanded the capabilities of analytical chemistry. With techniques becoming more refined and sensitive, it is possible to detect trace levels of substances, which is critical for fields requiring high precision, such as drug testing, environmental monitoring, and clinical diagnostics. The role of analytical chemists often extends to instrument development, method validation, and data interpretation, ensuring accuracy and reliability in chemical analysis. As technology advances, analytical chemistry continuously evolves, incorporating novel tools and methodologies. The intelligence and precision that analytical chemistry brings to scientific research and application make it an indispensable component of modern science.